Good morning. Good morning, everybody. Namaskar. This is Ina Suraj Singh speaking from Bharat, India on this day, January 2nd, 2022. संडे मैं सूरज सिंह भारत इंडिया से बोल रहा हूँ। आज सुबह के 4:19 January 2022 रविवार early morning, exactly it's not but 4:19 and AM. This is Suraj Singh speaking from Bharat, India on this day, and topic is same, quality and safety in New Year, day 2022. Civil field engineering, life, engineers, concrete specifications and contracts. You can say quality likewise. Red book, silver book, design construction is almost same. Yesterday I did different one because of new day of year, January 1st, and I tried to include COVID-19, and that was at length, and also I tried to include technical subjects, a combination of technical and what's currently happening, COVID-19. Of course, I have not written this in this title, but it's a very significant issue. It's happening around the world. Even our country is now impacted upon this very well. Adversely, you can say immensely it's impacted upon. And in coming times, really it shall be not interesting, I can say. It's a question of severe concern. It's a question of severe concern, like I'm concerned with quality issues, safety issues. Of course, I'm concerned with COVID-19 issue, which is, doesn't say any religion or doesn't say any profession or doesn't say, it impacts everyone from king to lowest person in hierarchy. We have to be very careful about, we have to be very serious about that. The year 2022 has started but doesn't say anything, nothing has changed. It's actually on higher highs, you can say. You can check whatever country, you can say any part of the world, but you don't see, you'll find all differences. Though there's no meaning now stating something with COVID-19 because everybody knows about that. Since for 2 years people have experienced this and you should know what is the impact of this. It may be Delta or Omicron or 12 Hepatitis Gamma or whatever it is means. It's going to impact your life, but there's no way out and you have to adjust with that. That's you have to do means. Only way is that keep protected, no other way. And if you can't be protected, means you will suffer. Certainly your family will suffer, your nations will suffer. There's no politics in this, no question of politics in this, because it's health and safety issue. And as far as health and safety issue is concerned, we should be very serious about that for safety, for health and for environment. All these three are around means if you are not safe, I'm not healthy. If I'm not safe, I'm not healthy. I have no good environment around me, and naturally means there's a deficiency in my life. That deficiency is not for stomach but for my mind, for my body. So safety, health and environment are very significant issues, and the safety comes when you talk of COVID, health issue comes when you are impacted, and environment issue means we spoil our future, and that's why we should be more concerned. As far as quality is concerned, you can see quality talk is nothing new. It's nothing new. You can see this is my identification address, and you can, as I always request and appeal that if you want to write something, this is my email ID suraj_engineer@yahoo.co.uk. If you wish, you can write to me about engineering, civil, and you can write to me about contracts, about certain clarification you want to get. You can write to me, and I I would suggest, I would request that if you wish, you can write. It's your privilege, and it shall be my privilege as well if I get your correspondence. I like to see what seriousness you have in that, because I'm interested in those people who are serious in life, and this is competency certificate. It's called Professional Engineer Certificate at an international level, and this is Chartered Engineer Certification, as well as this is membership, fellow membership of Institution of Engineers. I have explained to you many times about this, and of course, and we have issue of quality in works, quality in life, and also what we call concrete, most important material in world. Concrete, we have gone through many pages of this. This is very brief, in fact, it's not very explanatory yet. Reference, you can see these are references, and these references are important somewhere on this file. It is, you can say, I think we were somewhere here. If you go and see, we are talking about some testing, or water testing. We are talking about that is, we are going to reach there, right? We've gone somewhere to 129 or 138. I'm going to 159, more and more. It's not near that. Yes, 168 now. I think we are reaching some here. And we are 180. So bearing pads and putting bars, and now we are here in concrete. We've done this. So we have here here is water tightness test. I start with this because maybe we did something on this, but time has gone, and maybe I have to refresh that one. And it is grouting, etc. we have done, so leave it. Now I'm going to start with this page to 190. Alright, concrete testing of water retaining structures, and that's where we have to do conc testing. In this, if you see contents here, it's in this general, is scope, references, submittals. In general, testing is general, clearing and testing procedures, walls, roofs, disposal of water used for testing, and of course here is general in this testing of water retaining structures. This part of specification applies to testing of structures that is designed with intention of retaining water, and in this related section parts as follows. You can say general inspection and testing of hardened concrete, protective treatments of concrete, and BS 8007 code is code of practice for design of concrete structures for retaining of aqueous liquids. Is submittals contractor shall record and submit to engineer within 24 hours results of water tightness test carried out, and general water retaining structure shall be watertight when subject to external groundwater pressure or to tests as specified in this part. I'm just reading it because I explained to you before, and if required I explain as such. Contractor shall contractor shall test water tightness of water retaining structures, including storage reservoirs and you can say storage reservoirs and other miscellaneous structures that require to be watertight. All water used for testing shall be potable or irrigation one, and contractor make arrangements for supply and disposal of this water. Water retaining structures tested for water tightness after completion in accordance with following method as directed by engineer. You see, when I say directed or it is something to be done with the engineer, you have to be clear about this. Here engineer, again I repeat, here engineer does not mean site engineer. Engineer here is a designation, it's a contractual title. It's always mentioned in contract. This means engineer who is responsible for supervision of job, who is responsible on behalf of owner or client, who is responsible for finally authorizing work complete or item complete or done according to requirements. It is that position. It's not something ordinary. It is, you can say, legal position. So be careful about this when I say engineer. A structure shall be filled with potable or irrigation water in stages not exceeding 1 meter in 24 hours. That is limit. In 1 meter, we should not fill reservoir, we should not fill that tank, you can say more than 1 meter in 24 hours. And then we hold it, held at each water level for such time as engineer may require, and also you may say as codal requirement mandates. You have to see code, and read it. This is particular BS 8007 or equivalent Euro code you can consider. Should dampness or leakage occur? Should means if. If dampness or leakage occurs, water shall be drawn off and defects remedied to satisfaction of engineer. During test, during wait period, and if you think there is water leakage, water is flowing out through whatever portion of that section of concrete, this is called dampness or leakage. And it should be, water shall be drawn off. This means this is defect. You have to take off water from there. You have to apply remedial measures on that portion where leak appears, and then it should be to satisfaction of engineer or per specification requirements. Now, in case of structures which are subdivided into individual tanks, in case of those structures which are further subdivided into individual tanks, each individual tank shall be tested separately. There can be cases where a group of tanks are there and you have to test one by one. In case of underground or partially underground structures, underground, below ground structures, testing shall effect before application of waterproofing membrane. Means we are going to test concrete portion and not other portion. Therefore, it says that we have to test only concrete. In case of underground or partially underground structures, testing shall effect before application of waterproofing membrane or its liner material, membrane or liner material or perimeter tray. To test is done. That is what it says. You have to test blank tank, blank concrete in fact, not tank, concrete portion of tank. In case of hopper bottom tank, where is hopper bottom tank, you can say this shall be taken to mean that no material is placed against vertical external walls of tank. These are very important points, that's why I am trying to repeat. Sloping walls of hopper bottom of tank being assumed built directly against excavation apart from blinding concrete. No placing of material against walls shall affect. No placing of material against walls shall affect until engineer has given its written approval and acceptance of water retaining structures are watertight. Try to get this point. Engineer has to finally approve it. That approve and accept water retaining structures being watertight. Filling shall not affect. Filling shall not affect earlier than 28 days after casting of final section of structures. 28-day requirement before filling is done. Filling shall not affect earlier than 28 days after casting of final section of structure, which be stressed by filling of structures. Testing shall not be undertaken until structure to be tested has been completed structurally, including roof if it has, and been passed by engineer in writing as satisfactory in all respects other than water tightness, especially in regard to final finish of work. Notwithstanding satisfactory completion of 7-day test, notwithstanding satisfactory completion of 7-day test, leakage, cracks and damp patches, switching visible on outside faces of structure shall be rectified from water phase by an injection system to approval of engineer. Repair and repair making outer face only watertight shall not be accepted. Repair making outer face or watertight shall not be accepted. This applies to bobbin holes also. The structure shall be retested until water tightness is approved. The structure shall be retested until water tightness is approved by engineer. If should structure fail for a test, structure failure test, should structure failure test in above respects, contractor shall immediately take such steps as be necessary, that is, to ascertain nature and positions of defects or leakage. You have to make sure where is leakage existing. Ascertain nature and position of defects or leakage. Empty structure. The structure should be empty. Remedy defects in a manner approved by engineer, employing workers who are specialists in this class of work. So first is you have to make sure where defects do exist or mark them, or leakage or defects or whatever you can say, then empty it out. Then you apply remedy, you apply repairs in whatever manner approved by engineer based on specialist recommendations. Employ workers who are expert in this type of activity. When remedial work has been completed, when remedial work is completed in manner approved by engineer, testing and if necessary rectification be repeated until a satisfactory test is achieved. You be clear, even after remedial action is resorted to or effected, and you can test again, you have to test again. If there is another leakage, you have to do it again and again and again until you get satisfactory test conducted. If necessary, in extreme cases of lack of water tightness, engineer may reject structure or portions thereof. Very serious matter. Very serious matter that in case it is not found watertight, engineer will reject it or part portion of that. Do it again. And then we say cleaning. All water, all water tightness, all water retaining structures on completion be carefully cleaned of all debris to complete satisfaction of structure. As follows. How? It says all water retaining structures shall on completion be carefully cleaned of all debris. It's a process is telling about cleaning for purpose of testing. Shall be brushed down means brushed down all internal faces with a stiff broom while still dry. Clean them all using stiff brush all walls inside. Whatever debris are available, remove them. You get certain debris somewhere, very minor pieces, remove them. And you can say all associated reservoir pipe work be cleaned in accordance with requirement, whatever is there. Structure shall then be flooded with approximately 75 mm clean water, 75 mm from bottom. Fill it and you have to clean it, you have to wash it. You have to wash walls and floors. Whole interfaces be carefully brushed down with stiff brooms using water continuously until all faces are clean. Water shall then be dried off. Water shall then be dried off. Walls and floors hosed and flushed. Walls and floors hosed and flushed with clean water until after completion and cleaning of structure, after completion and cleaning of structure, and all associated pipe work, if it is there, not necessary it be there. Contractor shall fill structure up to top water level and leave for a stabilizing period of 21 days in order to allow for absorption and autogenous healing to effect. Absorption of water into concrete holes, into concrete voids, and autogenous healing to effect. This means complete saturation of volume of concrete so that there should be no delay in transmission of water through these voids. So after completion and cleaning of structures and all associated pipe work, if it exists or you have like in swimming pool or like somewhere, or you can say in treatment plant reservoirs, you can say contractor shall fill structure up to top water level following 1 meter in 24 hours principle and leave for stabilization period of 21 days. 21 days, remember, 3 weeks, in order to allow for absorption and autogenous healing to effect. Water shall be added. Water shall be added over this period to maintain top water level. You can say it's like top up, fashion to top up. Contractor shall ensure that all pipes and spatials are available in ample time ahead of testing. Now what we do? We require 2 sets of trays. We call it evaporation tray because there is no formula that can be used to calculate evaporation losses when tank is open. Of course, they shall affect evaporation. We have to measure evaporation so that our drop may not exceed whatever drop we have. We consider evaporation also. Two sets of evaporation trays be provided along with two sets of rain gauges. Because if evaporation is a question mark, rain is also a question mark, because during test, if it rains, we have to take that portion into our consideration when we decide final drop. Levels in trays and structure shall be made and recorded by a hook gauge with vernier attachment. Level in trays and structure shall be made and recorded by a hook gauge with vernier attachment. Before and during testing, flows in structure under drainage, if it has, before and during testing, flows in structure under drainage, if it has, shall be monitored, measured, and recorded. Each under drain shall be numbered and observations reported by under drain number to facilitate analysis of data. Each under drain shall be numbered. Each under drain shall be numbered and observations reported by under drain number to facilitate analysis of data. All leaks be repaired within 1 month of their detection. This is limiting period. All leaks shall be repaired within 1 month of their detection. On 22nd day, two shallow watertight evaporation trays. This is 22nd day. When we say after that, on 22nd day, it is 21 days, you can say wait period, then 22nd day, two shallow watertight evaporation trays. What I'm saying is 22nd, we talked of 21 days, that this is autogenous period, or you can say autogenous self-auto, it's absorption and autogenous period. So we have to start testing on 22nd days. Two shallow watertight evaporation trays of area 0.4 meters square, that is 1 meter, let us say 1 meter by 0.4, that's 0.4 meters square, or it can be some other size. It can be, if not 0.1 by 0.4, it can be 0.8 by 0.5. Yes, it can be 0.8 by 0.5, that's 0.4, or it can be, you can say, some other size which equals to 0.4 meter square, and whatever it can be, and shall be filled with 75 mm of water and placed to float in structure. So only 75 mm water thickness shall be placed in that. So it's not very big tray, it's very light tray, but should be stable. So we say on 22nd day, two shallow watertight evaporation trays of area 0.4 meter square shall be filled with 75 mm of water and placed to float in structure. And we have to fill 75 mm water. This means we should have at least 100 to 150 mm depth of that tray into the left minimum. Water level in structure shall be recorded and test commenced and carried out over next 7 days. This means 22 plus 7, in the 28 days, let us say 28 or 9, water level in structure be recorded and test commenced with and carried out over next 7 days. Readings of water levels in structure and trace be made and recorded every 24 hours over this period. Readings of water levels in structure and trace be made and recorded every 24 hours over this period. If water level in tank if water level in tank falls by more than indicated by evaporation trace. Here we have just one point. It says if water level in tank falls by more than indicated by evaporation trace, other sign of leakage occurs by end of test period, contractor shall search and mark all areas of defect. If water level in tank falls by more than indicated by evaporation trace or other signs of leakage occurs by end of test period, contractor shall search and mark all areas of defect. Structure shall then be emptied after we have marked these areas. Structure shall then be emptied and defects made good as specified herein. After completion of remedial measures, structure shall be refilled and test repeated. This process shall be repeated until the structure is watertight, or you can say successfully tested. This process shall be repeated until the structure attains a state of water tightness to satisfaction of engineer and compliance with requirements, and compliance with requirements means engineer satisfaction. Fall of water level in structure over test period of 7 days minus fall of water level in structure over test period of 7 days minus fall accounted for by evaporation and rainfall. Alright, minus is fall of water level in structure over test period of 7 days minus fall accounted for by evaporation and rainfall shall not exceed 1/500 of average water depth. Shall not exceed 1/500 of average water depth of full structure, or 10 mm, whichever is less. Very minute calculation it is. Testing of water in structure. Roofs now. Roof of structure shall be tested for water tightness before laying of roof membrane. We are talking of roofs. It's not very complicated, however, but interesting one because it is water test ultimately. It's not water retaining structures. It's a structure in that way only when there's rain and it opens and some water accumulates. So we are saying water test for that is also important because water can penetrate down into room below. Roofs of structures shall be tested for water tightness before laying of roof membrane, which shall be guaranteed for about 10 years. Roof and fittings roof and fittings shall be hosed down. Roof and fitting shall be hosed down vigorously, and this repeated in such a way as to keep roof wet for 3 successive days. Roof and fittings leaks or damp patches show in soffit. Soffit means internal surface of internal, or you can say below surface, bottom surface of slab. Roof and fittings shall be deemed satisfactory for water tightness if no discernible leaks or damp patches show in soffit. I repeat, roof and fittings shall be deemed satisfactory for water tightness if no discernible leaks or damp patches show in soffit. Roof covering shall be completed. Roof covering shall be completed as soon as possible after testing. Disposal of water used for testing. Contractor shall provide suitable means for disposal of water used for testing, such that no damage results to facilities, structure, or property. These means shall be subject to approval of engineer and local authorities. Details shall be submitted to engineer on request. Contractor shall be responsible for damage caused by its filling, testing, flushing, and wastewater disposal operations. That is, water testing we considered for this. So you should be very serious about this matter. Testing is very important. Now we come to part 20 of this specification, and that is personal qualifications and certification. In this we say personal qualification satisfaction, general auditors, ready-mix concrete companies, technical department, production and operation department, testing laboratories, concrete laboratories department, contractors, concrete construction department, consultants, site supervision department, site supervision design office department. Personal qualifications and certifications. In general it is qualification requirements given in this part are optional unless otherwise mentioned below. Purpose of qualifications is to prepare industry to cope with required quality of construction. This is purpose. Requirements shall become compulsory as and when stated by standards. So it is just their own proposal, but it basically says qualification is a requirement and it is not optional for me as I am concerned, but let us say it is a general statement. Purpose of qualifications is to prepare industry to cope with required quality of construction. Quality of construction. Purpose of qualifications is to prepare industry to cope with required quality of construction. Requirements become compulsory. The qualification shall be approved by standards or their representatives. Well, now auditors is for Qatar country, so it's written Qatar standards auditors and their approved representatives shall be qualified for inspection, for inspecting concrete ready-mix plants and testing laboratories. So we are talking about RMCs first, that RMCs, how they should be qualified. So it is ready-mix concrete companies we are talking of now. Ready-mix concrete companies, technical department. Technical department it is for them. What is position? Number one, that is technical manager or QC manager. Now, what should be qualification? What should be qualification there for technical manager or QC manager? Concrete specification review. Concrete specification review and concrete mixture proportioning. Concrete constituent materials, characteristics and effects on concrete properties. Fresh and hardened concrete properties. Durability of concrete. Production and delivery of ready mix concrete. Handling, placing and curing of concrete. Specifying and evaluation of concrete strength. Testing of concrete and its constituents. Quality control procedures and statistical analysis. Hot weather concreting. Troubleshooting concrete problems. This is for technical manager, QC manager, and you can say actually this is like job description related qualification that your technical manager, QC manager should know about what are concrete specifications and to review them from time to time. What is proportion of concrete mixture proportion, say ingredients. You may say they have designs of concrete ingredients and that's what is talking about, and that we have to keep reviewing because materials are never constant ingredient. They keep on changing from time to time. So that is what that design mix is. How many kilogram of cement, how many kilograms cement you have to use, and how many kilograms cement you have to replace with either supplementary cementing material like PFA, like GGBS, or like microsilica. That is called replacement of cement by these supplementary materials, so that concrete becomes more and more quality related, and you can say cracks may be avoided using this pozzolanic material proportioning, and how many kilogram of water to be used, and also how many other kilograms of whatever required in that. Maybe you can say whatever admixtures are to be used, plasticizers are to be used, you can say all that is a part of specification. And trial designs, concrete constituent materials and their characters and effects of concrete properties, as we said, admixtures, etc. So it is two items here very important: concrete specification review and concrete mixture proportioning, as well as concrete constituent materials, respective characteristics and effects on concrete properties, fresh and hardened concrete properties. So there are two concrete. Number one is fresh, when it's just delivered to you until it sets, and then after it starts setting, it starts gaining strength, and that's called hardened concrete. So you can say from manufacturing process of concrete to start serving, that's called fresh and hardened concrete properties. And then durability of concrete, we have to consider about how much that person knows about the durability of concrete. And you know, durability is very long process. how far concrete can work. Though it's just test one, it's just consideration here. You can't check whole durability because you are not there, and it takes years and decades for durability. So it's different point of view here. Durability of concrete, production and delivery of ready-mix concrete. This is important point here, that manufacture and duration. You have to produce concrete and you have to deliver it. Production and delivery of ready-mix concrete. How much these guys, these persons, the personal technical manager and QC leaders should know, both leaders, for production and delivery of ready-mix concrete. You can say description or understanding. Handling, placing and curing of concrete. We should know complete about that, how to handle it, how to place it, and how to cure it. These are wet concrete stages. Wet concrete stages, and very important one. Wet concrete stages, very important one. Therefore, these are of top importance. That is handling, placing, and curing of concrete. Handling, placing, and curing of concrete. Specifying and evaluation of concrete strength. You can say specifying and evaluation of concrete strength. Then testing of concrete and its constituents. Testing, everybody knows whatever testing is: slump test, temperature test, air void test, compressive strength test, core test, or all these testing of concrete and its constituents. Quality control procedures and statistical analysis. Hot weather concreting, these are very important point. Both quality control procedures, these are involved with concrete, wet concrete, and you can say fresh to hardened way duration. Quality control procedures and statistical analysis. Hot weather concreting, the temperature is most important. How to maintain it in hot weather conditions. Then troubleshooting concrete problems. So list is what? Again I say, concrete specification review and concrete mixture proportioning. Concrete constituent materials, their characteristics and effect on concrete properties. Fresh and hardened concrete properties. Durability of concrete. Production and delivery of ready-mix concrete. Handling, placing and curing of concrete. Specifying and evaluation of concrete strength. Testing of concrete and its constituents. Quality supervisor shall be capable of satisfactorily reading, understanding and performing below fresh concrete tests. Signals are down. Problem: no improvement. Initial signals, some only came. Supervisor shall be capable of satisfactorily reading, understanding and performing below fresh concrete tests. What is testing fresh concrete? Sampling fresh concrete. You know that slump test, generally it is temperature, what's temperature and air voids. We generally test all this. So testing fresh concrete, sampling, temperature of freshly mixed hydraulic cement concrete, temperature of that one. And also then you can say testing fresh concrete, and that is slump test we said. Testing fresh concrete, slump test. Testing fresh concrete density. Testing hardened concrete, making and curing specimen for strength tests. Standard test method for slump flow of self-consolidating concrete. Standard test method for slump flow of self-consolidating concrete. Self-consolidating means where there is no requirement of applying vibrator. Automatically it settles and densifies it. There is no need of compaction in this case. It's called standard test method for slumps flow and self-consolidating concrete. Actually, they call it self-consolidation, it's actually self-compaction. Now, position is laboratory supervisor. Laboratory supervisor. Laboratory supervisor is, technician in laboratory, and it's very important position. Technical position it is. It says supervisor. It is. Which one is that? I think. Hold on. Lab supervisor. Qualification is lab supervisor shall be capable of satisfactory reading, understanding, and performing these fresh and hardened concrete tests. Testing fresh concrete. What is about that? Sampling, cube, right? Testing fresh concrete, sampling, and just like the temperature we check, slump we check, and you can say all that. Temperature of freshly mixed hydraulic cement concrete. Temperature of freshly mixed hydraulic cement concrete. Testing fresh concrete, slump test. Testing fresh concrete, density. Testing fresh concrete, air content, pressure method. Air content pressure method. Testing hardened concrete, making and curing specimen for strength tests. Testing hardened concrete, making and curing specimen for strength tests. Standard test method for slump flow of self-consolidating or compaction concrete. Test hardened concrete. Testing hardened concrete, compressive strength of test specimen. Aggregate is method of sampling. Aggregate. Method of sampling, and then you can say in that same way you can say method of sampling. The methods of reducing laboratory sample. Determination of particle size, distribution, and dust contents. This is for aggregate. That method of reducing laboratory samples. And determination of particle size, distribution, and dust content. Aggregates, determination of particle density and water absorption. And aggregate also determination of loose bulk density and voids. Method of determination of moisture content. So how many points are there? Let us see. Because it is for laboratory one. Here you can say testing fresh concrete, sampling temperature of freshly mixed hydraulic cement concrete, testing fresh concrete, some test and density, testing fresh concrete, air content pressure method, testing hardened concrete, making and curing specimen for strength test, and standard test method for slump flow of self-consolidating concrete, testing hardened concrete, compressive strength test specimen, aggregates method of sampling, aggregates method of reducing laboratory samples, aggregates, determination of particle size distribution and dust content and aggregates, determination of particle size density and water absorption, aggregate determination of loose bulk density and voids, and method of determination of moisture content. Again, this site technician, compulsory if requested by engineer, and that is site technician. Test technician shall be capable of satisfactorily performing below fresh concrete test. What's that? Now which size was that? A site technician compulsory of required by engineer and his qualification technical technician shall be capable of satisfactorily performing below fresh concrete test, and that is sampling, testing fresh concrete sampling, temperature of freshly mixed hydraulic cement concrete, testing fresh concrete slump test, and testing fresh concrete density, testing hardened concrete, making and curing specimen for strength test and standard test method for slump flow of self-consolidating concrete. Then lab technician compulsory requested by engineer, and qualification is technician shall be capable of satisfactorily performing below fresh and hardened concrete test, and that is lab technician. Size testing fresh concrete, right? So technician shall be capable of satisfactorily performing these tests, fresh concrete tests and hardened concrete tests, testing fresh concrete sampling, again temperature of fresh mixed hydraulic cement concrete, testing of fresh concrete slump test, testing of concrete density, you can say testing fresh concrete all contents pressure method, testing hardened concrete, making and curing specimen for strength test, standard test method for slump flow of self-consolidating concrete, testing hardened concrete, compressive strength of test specimen, and aggregates method of sampling, and aggregates method of reducing laboratory samples, aggregates determination of particle size distribution and dust content, aggregates determination of particle density and water absorption, aggregates determination of loose bulk density and voids, method of determination of moisture content. Now we have operation department. Operation department, production and operation department, and position is plant production or operation manager and or supervisor or performer, you may say, whose qualification says it should have knowledge of properties of concrete and its constituents, materials management, organization, plant design, function and maintenance, batching operators, procedures and dispatching, materials management or materials organization management and inventory, and safety regulations and procedures. And let's say what's that? Plant operator. And what should be qualification of that plant operator? Let's see what says plant operator. Plant operator, which means basic concrete properties and characters of its constituents. Basic concrete properties and characteristics of its constituents, that is job of plant operator. Basic concrete properties and characteristics of its constituents, scales, meters and batching sequence and control system, central mixing and discharging tolerances, overweight, underweight, controls. Troubleshooting scales, gauges and other plant components, safety procedures. So its plant operators is basic concrete properties and characteristics of constituents, scales, meters, batching sequence and control system, central mixing and discharging, tolerance, overweight, underweight controls, and troubleshooting scale gates and other plant components and safety procedures. And now testing laboratory. Testing laboratory. Testing laboratory, concrete testing department. It has concrete testing department. In this position is laboratory manager or QC manager. Concrete specification review, as usual we said before, and concrete mixture proportioning. Concrete constituent materials, characteristics and effects of concrete properties. Fresh and hardened concrete properties, durability of concrete, production and delivery of ready-mix concrete, handling, placing and curing of concrete, evaluation of concrete strength, testing of concrete and its constituents, quality control procedures and statistical analysis, hot weather concreting, troubleshooting concrete problems. Same list here is as before, so no problem. That was batching plant, it's now laboratory. So I repeat again, it's very important one. Concrete specifications review and concrete mixture proportioning, concrete constituent materials, characteristics and effects of concrete properties, fresh and hardened concrete properties, durability of concrete, production and delivery of ready-mix concrete, handling, placing and curing of concrete, evaluation of concrete strength, testing of concrete and its constituents, quality control procedures and statistical analysis, hot weather conditions, hot weather concrete, troubleshooting concrete problem, and that troubleshooting is very important here. Troubleshooting means as a troubleshooting concrete problem, and we can say here, if we go further, then supervisor, the same position here, and that is now supervisors shall be capable of satisfactorily reading, you can say supervisors shall be capable of satisfactorily reading, understanding and performing blow fresh and hardened concrete tests. These are testing fresh concrete, sampling, temperature of freshly mixed hydraulic cement concrete, testing fresh concrete slump test, testing fresh concrete density, testing fresh concrete air content, pressure method, testing hardened concrete, making and curing specimen for strength test, standard test method for slump flow, standard test method for slump flow of self-consolidating concrete, testing hardened concrete, compressive strength of test specimen, aggregates method of sampling, and we can say aggregates method of reducing laboratory samples, aggregates determination of particle size distribution and dust content, aggregates determination of particle density and water absorption, aggregate determination of loose bulk density and voids, definition of loose bulk density and voids, method of determination of moisture content. And now technician also here is compulsory required, that is technician compulsory requested by engineer, and technician should be capable of satisfactorily performing blow fresh and hardened concrete tests. And that is testing fresh concrete, sampling temperature of freshly mixed hydraulic cement concrete, testing fresh concrete slump test, testing fresh concrete density, testing fresh concrete air content, and testing hardened concrete, making and curing specimen for strength test. Standard test methods for slump, flow of self-consolidating concrete, testing hardened concrete, compressive strength of test specimen, aggregates method of sampling. Methods, the aggregates methods of reducing laboratory samples and aggregates determination of particle size distribution and dust content, determination of particle size, particle density and water absorption, determination of loose bulk density and voids of all aggregates, and method of determination of moisture content, and now contractor. Contractor, concrete construction department, site engineer. Site engineer shall be capable of satisfactorily reading, understanding, and performing these fresh concrete tests. Again, fresh concrete, sampling, temperature of freshly mixed hydraulic cement concrete, testing fresh concrete slump test, testing fresh concrete density, testing fresh concrete air content, pressure method, testing hardened concrete strength test, making and curing specimen for strength test. Standard test methods for slump flow of self consolidating concrete. QC manager, QC engineer, material engineer. What they should be qualified for? Minimum concrete specification review and concrete mixture proportioning. Concrete constituent materials, respective characteristics and effects on concrete properties. Fresh and hardened concrete properties, durability of concrete, production and delivery of ready-mix concrete, handling, placing and curing of concrete, specifying and evaluating concrete strength, testing of concrete and constituents, quality control procedures and statistical analysis, hot weather concrete, troubleshooting concrete problems. I again speak about this list, very small but very important, and it's part of major quality on concrete, conducting major quality procedures on concrete, concrete specifications, which are very, you can say, descriptive, concrete specification review and concrete mixture proportioning, concrete constituent materials, characteristics and effects on concrete properties, fresh and hardened concrete properties, durability of concrete, production and delivery of ready-mix concrete, hardening, handling, placing and curing of concrete, handling, placing and curing of concrete, specifying and evaluation of concrete strength, testing of concrete and its constituents, quality control procedures and statistical analysis, hot weather concreting, troubleshooting concrete problems. Consultants, site supervision department, previous was site people, now it's consultants, site inspector, material inspector. Site engineer shall be capable of satisfactory reading. It is actually site consultant. Site consultant shall be capable of satisfactory reading, understanding and performing these fresh concrete test, as we said before, repetition of that. Testing fresh concrete sampling, temperature of fresh mixed hydraulic cement concrete, testing fresh concrete slump test, testing fresh concrete density, testing hardened concrete, making and curing specimen for strength test. Standard test method for slump, flow of self-consolidating concrete and site supervision, design office department. Site supervision, design office department, material engineer, concrete specification review, and concrete mixture proportioning. Concrete specification review is very common, concrete specification review and concrete mixture proportioning. Concrete constituent materials, respective characteristics and effects on concrete properties, fresh and hardened concrete properties, and durability of concrete, and then production and delivery of ready-mix concrete, handling, placing and curing of concrete, specifying and evaluation of concrete strength, testing of concrete and its constituents, quality control procedures and statistical analysis, hot weather concreting, troubleshooting concrete problems. And these are, again I repeat, important requirements in material engineer, that is concrete specification review and concrete mixture proportioning, concrete constituent materials, respective characteristics and effects on concrete properties, fresh and hardened concrete properties, durability of concrete, production and delivery of ready-mix concrete, handling, placing and curing of concrete, specifying and evaluating concrete strength, testing of concrete and its constituents, quality control procedures and statistical analysis, hot weather concreting, troubleshooting concrete problems. And for consult, you can say site supervision department, site inspector of material, and all says that this is what testing, etc. I discuss now qualification. In this case, a site engineer shall be capable, site supervisor or shall be capable of satisfactorily reading, understanding and performing below fresh concrete tests, testing fresh concrete sampling, temperature of freshly mixed hydraulic cement concrete, testing fresh concrete slump test and density, and testing hardened concrete, and that's making and curing specimen for strength test, and standard test method, test hardened concrete, and then standard method for slump flowing of self-consolidating concrete, and SQC material engineer. What should they do? Concrete specification review and concrete mixture proportioning, concrete constituent materials, their characteristics, respective characteristics and effects on concrete properties, fresh and hardened concrete properties, durability of concrete, production, delivery of ready-mix concrete, handling, placing and curing of concrete, specifying and evaluating concrete strength, testing of concrete and its constituents, quality control procedures and statistical analysis, hot weather conditions of concreting, troubleshooting concrete problems. And likewise, we have gone through this concrete chapter. Was little interested in something which is very uncommon, you can say, we can say now what is that cold weather concrete precautions, that is what you can say about that, best practices for cold weather concreting. Jack Holly webinar series, letting concrete trees, placing concrete on frozen ground, sending concrete out at improper temperature, not monitoring temperatures constantly, improper placing and finishing, increase cement, reduce supplementary cementitious material, and we can say, in fact, it is about best practice. I'm talking of cold weather concreting. This is very important one also, and it says what it says: environmental factors like hot and cold weather. Environmental factors like hot and cold weather affect concrete properties and construction operations of mixing, transporting, and placing of concrete materials. By understanding how these factors affect placing and curing of concrete, producers can adjust mix designs and compensate in a variety of other ways to maintain high quality standards and avoid issue with finished product. Jack Hawley, a concrete quality control veteran of 45 years, shares experience and recommends best practice for hot and cold weather conditions in two parts webinar series. So it's some reference what it says. The what's cold concrete, cold weather concrete. American Concrete Institute ACI defines cold weather concrete. Cold weather concrete. American Concrete Institute defines cold weather concrete as a period when average daily ambient temperature is below or expected to fall below 5 degrees Celsius or 40 degrees Fahrenheit for more than 3 successive days. Average daily temperature is average of highest and lowest temperature. You can say, it says average daily temperature is average of highest and lowest temperature during period from midnight to midnight. Average daily temperature is average of highest and lowest temperature during period from midnight to midnight. When temperature remains about 10 degrees Celsius or 50 degrees Fahrenheit occur during more than half of whatever 24 hours duration, period shall no longer be regarded as cold weather. But it says when temperature above 10 degrees Celsius occur during more than half whatever 24 hours duration, period shall no longer be regarded as cold weather. Cold weather concreting is when average daily ambient temperature is below 5 degrees Celsius for more than 3 successive days. Cold weather concreting is defined when average daily ambient temperature is below 5 degrees Celsius for more than 3 successive days. Common mistakes with cold weather concrete. Actually, here is little, let us say, if I can take print out of this and show to you is better, I think. Let me try out if I can print it, better for your reference, because as much better information you get, that shall be better. Otherwise, it will be problematic to know. I try to get it from this website I'm using for reference, and it's nice if you can view it. It comes out because yes, I think it's coming out in your interest. So let's keep safe. You can see it now, right? You can see it. I browsed in, and best practices for cold weather conditions. As I said, This is website here is, what is this website is? This carbon cure, and this is best practice for cold weather concrete carbon cure. This is November 12, 2020, 2 years back. And as I said, it says environmental factors like hot and cold weather affect concrete properties, and construction operations are mixing, transporting, and placing of concrete materials. By understanding how these factors affect placing and curing of concrete, producers can adjust mix designs and compensate in a variety of other ways to maintain high quality standards and avoid issues with finished product. And it's a concrete quality can as I said, American Concrete Institute ACI defines cold concrete concreting as a period when average daily ambient temperatures below are expected to fall below 5 degrees Celsius for more than 3 successive days, where average daily temperature is average of highest and lowest temperature during period from midnight to midnight when temperature falls below 10 degrees Celsius occur during more than half of any 24 hours duration. Period shall long be regarded as cold weather. Cold weather concretes when average daily temperature falls below 5 degrees Celsius for more than 3 successive days. Common mistakes with cold weather concrete, and that is must be taken cold weather concrete. Special precautions must be taken in cold weather concrete to prevent damage to concrete. To prevent damage to concrete, necessary degree of protection increases as ambient temperature decreases, and these are the mistakes which do. Letting concrete freeze, that's a mistake. Common mistakes include letting concrete freeze, it's not possible. Concrete temperatures should be maintained below 10 degrees Celsius. Concrete temperatures should be maintained below 10 degrees Celsius until expected strengths have been reached. Until expected strengths have been reached after finishing process. If concrete freezes prior to reaching an initial strength 3.5 MPa, so if concrete freezes prior to reaching an initial strength of 3.5 MPa, it shall not achieve its intended strength. This is the condition here, 3.5 MPa. If concrete freezes prior to reaching an initial strength of 3.5 MPa, it shall not achieve its intended strength. Exterior concrete should be air entrained. Exterior concrete should be air entrained and at minimum required strength prior to exposure to freezing and thawing cycles. Then we can say number 2 is missing, I think, no issue. This is no problem. Let's say sending concrete out at improper temperature. Let's say one more thing. Further fresh concrete closer to ground shall cure slower than surface, meaning top of your slab sets while bottom stays soft, resulting in surface defects like cracking or crushing. Further fresh concrete closest to ground shall cure slower than surface, meaning on top of your slab set while bottom stays soft, resulting in surface defects like cracking or crusting. Sending concrete out at improper temperature. Need for proper planning. It needs proper planning. In cold weather condition, in cold weather cannot be overstated. According to this requirement, concrete should arrive at a site on time and from a production standpoint. Water and aggregate should be heated to maintain proper temperature. Very important point. Water and aggregate should be heated to maintain should be heated to maintain proper temperature. One of best ways to do is with blends of hot water, warming sand, and even blending sand in colder areas. What's way? Is with blends of hot water, warming sand, and even blending sand in colder areas. Not monitoring temperature constantly. These are all mistakes we are saying. You got it point? Mechanical and personal resources should be on site. Mechanical and personal resources should be on site to monitor temperatures at all times. One of the best ways to do it is with a temperature calculator from ACI. Take temperature of all materials, calculate output temperature of concrete, target your water temperatures, and make other adjustments. There are temperature sensors available today that can be easily installed in concrete as it is placed. These sensors can send data wirelessly so you can monitor and foresee potential issues or changes in set time. Again I repeat, this is temperature control, temperature constantly. Mechanical and personal resources should be on site to monitor temperatures all times. Best way to do is with temperature calculator. Take temperature of all materials, calculate output temperature if of concrete, target your water temperature, and make other adjustments. Temperature sensors available today that can be easily installed in concrete as placed. These sensors can send data wirelessly so that you can monitor and foresee potential issues or changes in set times. Improper placing and finishing. Removing, heating and hoarding. Removing, heating and hoarding too quickly after curing period has ended shall cause a rapid cooling. Removing, heating and hoarding too quickly after curing period has ended shall cause a rapid cooling of outer surfaces and create a thermal differential within placement. There are recommended time limits that can be referred to through Portland Cement Association. Create a thermal differential within placement. There are recommended time limits that can be referred to through Portland Cement Associations, ACI and other industry bodies. If those limits are exceeded, there's a high possibility that structures crack down due to differential in temperature. Continue to monitor until differentials are equalized. Continue to monitor until differentials are equalized or at a small enough number that it won't create stresses within placement. For colder climates, if you have a water curer, it's best to remove it a day prior to removing heat to prevent freezing in a saturated situation, depending on how mature process concrete is. For colder climates, if you have water curer, it's best to remove it a day prior to removing heat to prevent freezing in a saturated situation. depending on how mature process concrete is. Concrete, mixed design adjustment in cold concrete, and that is here. Recommendation is examining mixed designs and making adjustment as you come into fall season. Fall season, can say, to help with cold weather concreting. The following are some, you can say here. Adjust admixture, reduce supplementary cement. Before that, we can say some procedures add 50 to 60 kilogram per cubic meter of type 1, type 2 cement. Some procedures add 100, or you can say 50 to 60 kilogram per cubic meter of type 1 or type 2 cement. Others add type 3. A high early strength cement, that is ground finer and reacts faster, so early compressive strength gains are greater. However, none of these options are very efficient or cost effective for producers. So what it says, 50 to 60 kg per cubic meter type 1 or type 2 cement. Others add type 3, a high early strength cement, that is ground finer and reacts faster, so early compressive strength gains are greater. However, none of these options are very efficient or cost effective for producers. Reduce supplementary cementitious materials. Cutting back on percentage of SCMs is a common practice, but it depends on application. For flat work, you need to be a little more cautious and attentive with your initial sets. So you can say adjust admixtures. If normal water reducer had been evaluated, you can say if normal water heater, normal water reducer had been elevated, if normal water reducer had been elevated to near maximum limit, if normal water reducer had been elevated to near maximum limit for summer months, this should be moved back. If normal water reducer had been elevated to near maximum limits for other common adjustment in cold weather. However, don't want to decrease water reducer retarding past point of moderate reduction, and you start to have workability problem. Use accelerators. There are two types of accelerators, chloride based and non-chloride based. Chloride based accelerators are best, but they are limited due to corrosion potential of reinforcing steel. Non-chloride accelerators work well if manufacturers' recommendations for dosages are followed. Carbon cure and cold weather. Let me save this file also for future references, is better, so that we can have, you can say, let me save it sometimes somewhere, so that it is used and referred to. Let me see, cold weather concrete, general records, and I take facilities itself. concrete specifications. Where is this? I don't know. Anyway, I sell somewhere. Method shift, I think so, is it? Storage and management documents, yes. Management documents, where is that? Management documents, let's say this is on sort and okay, where I paste somewhere here now. Class. Carbon cure has been used. Carbon cure has been used for many years in cold weather conditions. It is a carbon cure has been used for many years in cold weather conditions. It won't contribute to any of issues described above, nor shall it prevent any of them. While carbon dioxide is a cooling material, carbon cure technology only uses a very small amount of carbon dioxide. Carbon cure technology only uses very small amount of carbon dioxide, not significant enough to alter temperature of concrete. Well, it says, I think there is only how precast and pre-stressed concrete producers can reduce carbon and profits. And here is concrete producers. I don't think something there in. So let's go back here and let me see another site. Let me close this site, see another site here. If I can find something more important on this, let us see. Let us see other site. If it say cold weather concrete and best practices for cold weather concrete, a carbon cure, and what it says, let us see. Then it's cement.org, cold weather concrete Porters Metal Association. It says cold weather concrete. And let's go one by one, it's better. Cold weather concrete Porters Metal Association, it is right now. Carbon cure, let's what it says, carbon cure. Carbon cure, best practice for cold weather concrete. I think it's saying water weather concreting, cold weather concreting. It says, no, it's saying, no, it's saying carbon cure. No, it's not. Let's go to say cement.org. What it says, let's see. Cold weather concrete. What cement.org says. What cement.org says. Let's see. Are you opening or not? It's taking a lot of time, so I'm asking this question. It's taking cold weather concrete thing. It's not opening, I think. There's some problem. It opens. What happens when cold concrete? Let us see. Let us read this point also. And let me see this. Let's take print out of this and let's have this work. So we can also share it. And we can view that for that purpose. It says, and let's see printed. What this says, the important point here. I mean, just minutes, you'll see in seconds, few seconds, you'll see this. And it's that's what says what happens when concrete freezes. And what happens when concrete freezes? Let's say weather conditions at a job site, hot or cold. Weather conditions at a job site, hot or cold. Let me just put off switch. What happens when concrete freezes? It's another website, and I'm just trying to refer because it's also very important, though it's not applicable in Gulf countries, but also not in my country as well, or in some parts of our country like Jammu, Kashmir, Shimla. What happens when concrete freezes? What happens when concrete freezes? And that just says what happens when concrete freezes. It's an important point here. What happens when concrete freezes? Weather conditions at a job site. Weather conditions at a job site: hot or cold, windy or calm, dry or humid, may be vastly different from optimum conditions assumed at time of concrete mix is specified, designed or selected, or from laboratory conditions in which concrete specimens are stored and tested. Concrete can be placed in cold weather conditions provided adequate precautions are resorted to alleviate negative impacts of low ambient temperatures. American Concrete Institute definition of cold weather concrete. What it says, that one, all concrete must be protected from freezing until it has reached a minimum strength, that is 500 pounds per square inch, which typically happens within first 24 hours. All concrete must be protected it says, very important point here. Again I repeat this paragraph, it's an important one. Weather conditions at a job site, hot, cold, windy or calm, dry or humid, may be vastly different from optimum conditions assumed at time concrete mix is specified, designed or selected, or from laboratory conditions in which concrete specimens are stored and tested. Concrete can be placed in cold weather conditions provided adequate precautions are resorted to alleviate negative impacts of low ambient temperatures. That's what we have to do. All concrete must be protected from freezing until it has reached a minimum required strength, which typically happens within first 24 hours. If concrete freezes while it is still fresh or before it has developed sufficient strength to resist expansive forces associated with freezing water, ice formation results in disruption of cement-based matrix, causing an irreparable loss in strength. Early freezing can result in reduction up to 50% in ultimate strength. Once concrete has attained a compressive strength of around 500 psi, it is generally considered to have sufficient strength to resist significant expansion and damage if frozen. Whenever a temperature at the time of concrete placement is below 40 degrees Fahrenheit and freezing temperature within first 24 hours after replacement are expected temperature as delivered. During cold weather, it may be necessary to heat one or more concrete materials. During cold weather, it be necessary to heat one or more of concrete materials, water and or aggregate, to provide proper concrete temperature as delivered. Due to quantities and heat capacity of cement, using hot cement is not an effective method raising initial concrete temperature. Protection while concrete is placed, consolidated and finished. Exposure of concrete to cold weather. Exposure of concrete to cold weather shall extend time required for it to reach initial set, which may require finishing crews to be available for a longer period. Depending on actual ambient temperature, protection of concrete placement may require use of windbreaks. Depending on actual ambient temperatures, protection of concrete placement may require use of windbreaks, enclosures, or supplementary heat. It may also be appropriate to adjust heavy heated enclosures are very effective. Heated enclosures are very effective for protecting concrete in cold weather, but are probably most expensive option. Enclosures can be made of wood, canvas, tarpaulins, or polyethylene. Prefabricated rigid plastic enclosures are also available. Three types of heaters are used in cold weather construction: direct fired, indirect fired, and hydronic subsystems. To avoid carbonation of fresh concrete surfaces, indirect fire heaters should be used. If concrete is not exposed to heater or exhaust directly, a direct fired heater is suitable. Caution should be taken to ensure that workers are not overexposed to carbon monoxide. Whatever time and any time a heater is used inside enclosure. Hydronic system transfer heat by circulating glycol water solution in a closed system. Hydronic systems transfer heat by circulating a glycol water solution in a closed system of pipes or hoses. Typical applications for hydronic systems include thawing and preheating subgrades and heating areas that are too large to be practical for an enclosure. Quality concrete. Curing to produce quality concrete. Curing not only requires added moisture but also appropriate temperature. Temperature of concrete as placed should be above 40 degrees Fahrenheit using methods described above. However, duration of heating is dependent on type of service. For concrete, ranging from 1 day for high early strength concrete that is not exposed to freeze thaw events during service to 20 days or more for a concrete element that would carry large loads at early age. In structures that carry large loads at an early age, concrete must be maintained at minimum 50 degrees Fahrenheit to accommodate stripping of forms and shoring and permitting load of structure. It's also important to prevent, let me say, just a minute, concrete retained in forms. Hold on, I think I missed something here. Load of structure, permit load of structure, and here is. In no case should concrete be allowed to freeze during first 24 hours after it has been placed. Since cement hydration is an exothermic reaction, concrete mixture produces some heat on its own. Protecting heat from escaping system using polyethylene sheeting or insulating blankets may be all that is required for good concrete quality. More severe temperatures may require supplemental heat. Again, I say in no case should concrete be allowed to freeze within 24 hours of its placements. Since cement hydration is an exothermic reaction, concrete mixture produces some heat of its own. Protecting that heat from escaping system using polyethylene sheeting or insulating blankets may be all that is required for good concrete quality. More severe temperature may require supplemental heat. Concrete drain forms covered with insulation seldom loses enough moisture. Concrete retained in forms or covered with insulation seldom loses enough moisture to impair curing. However, drying from low winter time, humidities and heaters used in enclosure is a concern. It's a good practice to leave forms in place as long as possible. Because they help distribute heat more evenly and help prevent drying of concrete. Live steam exhausted into an enclosure around concrete is an excellent method of curing because it provides both heat and moisture. Says live steam exhausted into an enclosure around concrete is an excellent method of curing because it provides both heat and moisture. Liquid membrane forming compounds can also be used within heated enclosures for early of concrete. Upon termination of heating period, sudden cooling of concrete surfaces while interior is warm may cause thermal cracking. Methods for gradual cooling of concrete include loosening of forms while maintaining cover with plastic sheeting or insulation, gradual decrease in heating inside the enclosure, or turning off heat and allowing enclosure to slowly equilibrate to ambient temperature. Massive structures may require several days or even weeks of gradual cooling to mitigate probability of thermal cracking. It's also important to prevent rapid cooling of concrete upon termination of heating period. Sudden cooling of concrete surface while interior is warm may cause thermal cracking. Methods for gradual cooling of concrete include loosening of forms while maintaining cover with plastic sheeting or insulation. Gradual decrease in heating inside enclosure or turning off heat and allowing enclosure to slowly equilibrate to ambient temperature. Massive structures may require several days or even weeks of gradual cooling to mitigate probability of thermal cracking. I also save this file. It's better. Save this file, and I'm going to cold weather concrete. Let's save this. That is now I close this file and try to open other one. Let me see where I can find that. This is now I'll take this back, and this was now I'll say what's that, cement.org. matrix cold weather concreting, matrix smart monitoring, cold weather concreting, which I think scientific. Let's say precast.org and precautions for cold weather concreting. Cold weather concreting is NRC hold that coated concrete says PSC documents for what's this PDF document it is, and it's good one to 12 pages. So I'll say large C. You must see this document here. Right, we have seen this now. It's the requirements for hot weather, and it says likewise. Let me see. Okay, requirements for hot weather. Requirements for hot weather, size. Let's see what it says. Let's see what the size. It is now 156. About not know exactly towards solid. Requirements for hot weather. IAO standards and specifications provide that whenever ambient air temperature exceeds 90 degrees Fahrenheit, hot weather concreting procedures shall be used. ACI standards 305 hot weather concreting is summarized in this section to provide guidance to field offices so that compliance with these provisions can be assured. Hot weather hot weather introduces problems in mixing, placing and curing concrete that can adversely affect properties and serviceability of hardened concrete. High temperature accelerates hardening of concrete. Higher temperature, more mixing water is generally required for same consistency. If water cement ratio is not maintained by adding additional cement, strength shall be reduced. Higher water contents also mean greater drying shrinkage. In very hot weather, fresh concrete may be plastic only an hour or less before it hardens. Hot weather is considered to be a combination of high air temperature. Hot weather is considered to be a combination of high air temperature, low relative humidity. High air temperature, low relative humidity and wind velocity tending to impair quality of fresh or hardened concrete or otherwise resulting in abnormal properties. Difficult to define in terms of temperature alone. Climatic factors affect concrete in hot weather are high air temperature, reduced relative humidity, effects of which may considerably more pronounced with increase in wind velocity. Effect of hot weather are more critical during period of rising temperature, falling relative humidity or both. They generally occur during summer season. Precautionary measures required on a calm, humid day will be less strict drying required on a dry, windy day, even if air temperature is identical. In lower hot weather, precautions should be considered when air temperature is above 85 degrees Fahrenheit. Hot weather effects. Actually, I was looking for cold weather, hot weather, no problem, it's okay. It doesn't matter. We have to learn something. More and more references are better to understand more and more. In absence of special precautions, undesirable hot weather effects, what are these? May include increased water demand for required consistency, difficulty in control of air entrainment, rapid evaporation of mixing water, Rapid slump loss making concrete mix more difficult to work, accelerated set. Difficulties with normal handling, finishing and curing. Greater dimensional change on cooling of hardened concrete. Increased plastic shrinkage. Increased tendency to crack or crease. Reduced durability from increased water demand and cracking, reduced strength. So we can see increased plastic shrinkage, increased tendency to crack or crease, reduced durability from increased water demand and cracking, reduced strength, variations in appearance of concrete surface, reduced bond of concrete to reinforcing steel, and increased risk of steel corrosion from increased permeability and cracking, possible cold joints, increased permeability. Let us repeat. Says increased water demand for required consistency, difficulty in control of entrained air, rapid evaporation of mixing water, rapid slump loss making concrete mix more difficult to work, accelerated set, difficulties with normal handling, finishing and curing, greater dimensional change on cooling of hardened concrete, increased plastic shrinkage, increased tendency to crack or crease, reduced durability from increased water demand and cracking, reduced strength. Then variation in appearance of concrete surface, reduced bond of concrete to reinforcement steel, and you can say increased risk of steel corrosion from increased permeability and cracking, possible cold joints, increased permeability. Now production and delivery is that if proportioning and mixing controls or delivery schedules are such that concrete arrives for placement in an unsuitable condition, desirable placing and curing practices are not possible. Control of concrete temperature through temperature of ingredients can only be done at point of mixing. That is, control of concrete temperature through temperature of ingredients can only be done at point of mixing. For concrete of conventional proportions, a reduction of concrete temperature of 1 degree Fahrenheit requires reducing either cement temperature about 8 degrees Fahrenheit, water temperature about 4 degrees Fahrenheit, or aggregate temperature about 2 degrees Fahrenheit. So you can cement temperature 8 degrees, water temperature 4, and aggregate temperature 2, so it is in that proportion 8 for 2, half and half. Since greatest portion of concrete is aggregate, reduction of aggregate temperature brings about greater reduction in concrete temperature. Since greater portion of concrete is the aggregate, reduction of aggregate temperature brings about greatest reduction in to keep concrete as cool as possible. You can say aggregate temperature brings about greatest reduction in concrete temperature. Thus all practical means should be employed to keep the aggregate as cool as possible. This can be done, by example, by shading supplies, sprinkling of fog spring of coarse aggregate, stockpiling is effective in reducing aggregate temperature by evaporation or operative and direct controlling. You can say temperature by evaporative and direct controlling, and you can say such sprinkling should not be done haphazardly because it leads to excessive variation in you can say surface moisture and thereby impairs uniformity of slump. Benefits, however, are valuable and warrant close attention. Cooling of mixing water. Cooling of mixing water and or use of ice is important. Temperature of water is easily lowered, and even though water is used in smaller quantities than other ingredients, use of cold mixing water will affect a moderate reduction in concrete placing temperature. Tanks and pipelines carrying mixing water should be buried, insulated, shaded, or painted, while to maintain water at lowest practical temperature. When ice is used as part of mixing water, it must be completely melted by time mixing is completed. Crushed or flaked ice is very effective in reducing concrete temperatures. For example, let's say mixing time should be held to minimum. Mixing time should be held minimum, which ensures adequate concrete quality and uniformity, because concrete is warmed from work of mixing, from air and from sun. Effect of mixer surfaces exposed to hot sun should be minimized. Effect of mixer surfaces exposed to sun are minimized and painted. You can say what is that? Effect of mixer surfaces exposed to hot sun should be minimized by painting and keeping mixer drum white, spraying it with cool water. White surfaces may be cooler than aluminum, and maybe as much as cooler than black or dark gray. Mixer drum and blades should be checked frequently during hot weather for buildup of cement and mortar, which reduce mixer efficiency. Cement hydration, temperature rise, slump loss, aggregate grinding, and loss of air all increase with places of time. Thus, period between mixing and cement hydration, temperature rise, slump loss, aggregate grinding, and loss of air all increase with passage of time. Thus, period between mixing and delivering should be kept to an absolute minimum. It says cement hydration, temperature rise, slump loss, aggregate grinding, and loss of air all increase with passage of time. Thus, period between mixing and delivery should be kept to an absolute minimum. Why? With ready mix concrete operations. This presents some special problems. Attention should be given to coordinating and dispatching of trucks with rate of placement to avoid delays in delivery. When elapsed time from batching to placement is so long as to result in significant increase in mixing water, demand, or in slump loss, mixing in truck should be delayed until only sufficient time remains. To accomplish mixing before concrete is placed, laboratory research as well as field experience suggests that strength reduction as well as other detrimental effects of hot weather is directly proportional to amount of retempering water added. On arrival at job site, addition of water should not be allowed other than that required to adjust to a specified slump. Within limit of specified maximum water ratio. Within limits of specified maximum water cement ratio. Preparation before placing. Before concrete is placed, certain precautions can be taken during hot weather to help we can say just a minute please, let me see if I can save it. Before concrete is placed, certain precautions can be taken during hot weather to help lower concrete temperature. Mixers, chutes, belts, hoppers, pump lines and other equipment for handling concrete can be shaded, painted white or covered with wet burlap to reduce effect of sun's heat. Forms reinforcing steel and subgrade should be sprinkled with cool water just prior to placing concrete. Wetting down area cools surroundings air and increase its relative humidity. This not only reduces temperature rise of concrete but also minimizes evaporation of water from concrete during placing. For slabs on ground, it is good practice to dampen subgrade evening before concreting prior to placing concrete. There should be no standing water or puddles on subgrade. When daytime temperature and drying conditions make it critical, scheduling concrete placement to begin in late afternoon shall materially improve placing conditions. On massive slabs and pavements, this has been found to result in much less thermal shrinkage and cracking. Concrete placed during early morning may attain an undesirably high temperature. Concrete placed during early morning may attain an undesirably high temperature, however, particularly trying middle of day. Middle of day when maximum sun radiations and heat of hydration occur. Such concrete could subsequently be exposed to several thermal stresses on concrete. Curing and protection. Should be emphasized that in hot weather there is a great requirement for continuous curing, preferably by water. Need is greatest during first few hours and in fact throughout first day after concrete is placed. All surfaces should be protected from drying even intermittently for a curing period of at least 7 days. After placement, as this contributes to development of pattern cracking, this can be done by use of fog sprays, wet burlap or other means of keeping concrete continuously moistened. Finishing of slabs and other exposed surfaces should be started as soon as condition of concrete allows and completed without delay. Exposed surfaces should be covered as soon as finishing is completed and kept continuously wet for at least 7-day curing period unless white pigmented curing compound is applied. Forms should be loosened as soon as it can be done without damage to concrete and provisions made for curing water to run down inside them. During form removal, care should be resorted to provide wet cover to newly exposed surfaces to avoid exposure to hot sun and wind. From cone holes can be filled and where necessarily repairs made for uncovering a small portion at a time as necessary to carry on this work. These repairs should be completed as soon as possible after forms are removed so that repairs and cone hole fillings can cure within surrounding concrete. Curing compound should not be applied until after cone holes are filled and repairs are made. Providing proper temperature and moisture conditions for curing of concrete is much more critical in hot weather than under normal temperatures. It's of utmost importance that curing be promptly commenced, ample in coverage, and continued without interruption. Requirement for cold weather. EVO standards and specifications provided whenever ambient temperature drops below 40 degrees Fahrenheit, cold weather concreting procedure be used. ACI Standard 306 cold weather concreting is summarized in this section to provide guidance to field offices so that compliance with these provisions can be assured. In general, precautions must be resorted to when placing concrete during the winter months to ensure that it has strength and durability to function properly. Concrete should be insulated or housed and heated after placement. Concrete should be insulated. Such precautions must be resorted to when placing concrete during winter months to ensure that it has strength and durability to function properly. Concrete should be insulated or housed and heated after placement. Temperature of concrete and air adjacent to concrete should be temperature of concrete and air adjacent to concrete should be maintained in specified rates for 7 days period following placing. Plans for protecting fresh concrete from cold weather should be made well in advance of freezing temperature. All needed equipment and materials should be at work site and ready to use before concrete is placed. It's too late to begin planning protective measures after concrete has been placed and its temperature being to approach freezing. Preparation before concreting. Before concreting is started, all ice, snow and frost should be completely removed from interior of forms and from reinforcing steel and parts to be embedded. Temperature of all surfaces to be intact with concrete should be raised as nearly as possible, practicable. Temperature of all surfaces to be in contact with concrete should be raised as nearly as practical to temperature of fresh concrete for to be placed. Concrete should never be placed on a frozen subgrade or on a one that contains frozen materials. Prior to placement of concrete, subgrade may be protected from freezing by covering it with straw or tarpaulins or plastic sheets or other insulating blankets. Temperature control as placed heating of materials. Now let me go for 5 minutes and come back, and meanwhile you can read this. 30 minutes, over 30 minutes. I'll be back in 5 minutes. Just go up and come back. You can meanwhile keep reading this. No issue. Just for 5 minutes, I'll be back. So back again, sorry gentlemen. I just wanted to share this with you. Let's now say temperature of concrete living mixture should be no higher than necessary to assure that concrete after exposure during transplant, say temperature of concrete is placed, page 5 of 12. Temperature of concrete living mixture should be no higher than necessary to assure that concrete after exposure during transporting and placing shall have a temperature not more than a few degrees higher than specified minimum. Temperature of exposed concrete depends on atmospheric temperature, but rarely is it necessary for concrete living mixture to be warmer. Current SCS specifications provide that temperature of concrete at time of placing should not be less than this. It's in Fahrenheit, actually it should be Celsius, should be 32 degrees Celsius, not more than that. Overheating of concrete is objectionable. Overheating of concrete is objectionable because it may accelerate chemical action. Overheating of concrete is objectionable because it may accelerate chemical action, cause excessive loss of slump, and increase water requirement for given slump. Moreover, warmer concrete as placed greater drop to ultimate low temperature with corresponding increase in thermal shrinkage. To obtain required temperature for freshly mixed concrete in cold weather, it is necessary to heat mixing water or aggregate, or both, depending on severity of weather. Heating of mixing water is most practicable and efficient procedure. Water is not only easy to heat, but each pound of each water unit heated to a given temperature has roughly 5 times as many available heat units. Units are rare area in pound of aggregate or cement at same temperature. It says water is not only an easy to heat, but each unit of water heated to a given temperature has roughly 5 times as many available heat units as are in pound of aggregate or cement at same temperature. Mixing water should be heated in such a manner and in sufficient quantity that appreciably fluctuates in temperatures from batch to batch are avoided. Very hot water should not be allowed to touch cement because of danger of causing quick or flash set. If hot water and coldest portion of aggregate can be brought together in mixer, if hot water and coldest portion of aggregate can be brought together in mixer, first, so that temperature of this mixture does not exceed required degrees, possibility of flash set shall be minimized and advantage can be taken of high water temperature. If heating of aggregate is used as an alternative method, aggregate should be heated uniformly and carefully, eliminating all frozen lumps, ice and snow, avoiding overheating or excessive drying. Unless temperatures are uniform, noticeable variations in water requirement and slump shall occur. Average temperature should not exceed defined one, for temperatures much above this may crack aggregate. Heating aggregate is preferably accomplished by steam or hot water in pipes. Heating with steam jets is objectionable because of resulting variable moisture in aggregate. Experience has demonstrated that variable moisture can be exceedingly troublesome. On small jobs, aggregates may be thawed by heating carefully over metal curves point in which fires are maintained. Exposed surfaces of aggregates in stockpiles, bins, etc. should be covered with tarpaulins during heating to obtain a uniform distribution of heat and avoid frozen crust. Protection. Protection required in cold weather is only that necessary to keep temperature of concrete from falling below certain degrees. Protection required in cold weather is only that necessary to keep temperature of concrete from falling from below certain degrees. Protection required in cold weather is only that necessary to keep the temperature of concrete from falling inadequately. Adequate protection can often be provided by conserving heat of hydration generated by hardening concrete. Conserving heat of hydration generated by hardening concrete. Heat may be retained in concrete by using commercial insulating blanket. Let me see what time is now. Important point is, okay, we have enough time. Heat may be retained in concrete by using commercial insulating blanket or batt insulation. Effectiveness of insulation can be determined by placing a thermometer under insulation in contact with concrete. If temperature falls below minimum required, additional insulating material should be applied. Corners and edges of concrete are most vulnerable to freezing. Corners and edges of concrete are most vulnerable to freezing and should be checked to determine effectiveness of protection. Forms built for repeated use often can economically be insulated. Commercial blanket or batt insulation used for this purpose should have a tough moisture-proof covering to withstand handling, abuse and exposure to weather. Enclosures for heating may be made of wood, canvas, wallboard, plywood, waterproof paper, plastic sheeting or other suitable material. A wood framework covered with tarpaulins or plastic sheets is commonly used. Enclosures should be sturdy and reasonably airtight, with sufficient space for circulation of warm air. Openings for access should be few and preferably should be self-closing. At least they should be easily closed. Heat may be supplied by live or piped steam, by salamanders or stoves of various types, or by airplane heaters located outside and enclosures, outside enclosures. Salamanders and stoves are easily handled and inexpensive, are convenient for small jobs, but the disadvantages of producing dry heat, of emitting fumes and smoke which often disfigure work, and on being fire hazards. They often cause fire losses which would more than offset cost of live steam heating, even on relatively small jobs. If salamanders or stoves are used, they should be blocked up to avoid damage to slab on which they are resting, and vent to outside to prevent carbonation damage to exposed concrete surfaces. Adequate firefighting apparatus should be on job all times to ensure continuous operation of heating units and protection from fire hazards. Housing and enclosures should be left in place for entire 7-day curing period, except that sections may be temporarily removed as required to permit placing additional forms or concrete, provided they are replaced as soon as forms or concrete is in its final position and uncovered concrete is not frozen, and provided time lost from required period of protection is made up at required temperature before protection is discontinued and removed. Rapid cooling of concrete at end of heating period should be avoided. Sudden cooling of concrete surface while interior is still warm may cause cracking. Cooling should be gradual. So maximum drop in temperature throughout first 24 hours shall not be more than given in table. Gradual cooling can often be accomplished by simply shutting off heat and allowing enclosure to cool to outside air temperature. We'll continue this and see if we can find more information from our sources, and that's what we think of. This is already, I think, it's 2 hours 40 minutes. We have to understand actually what we are doing, and that's a very important point here in our relations to this work. I'm just closing this for time being, and we'll see if we can get more dependence on this, and that's a very important point. I'm now going to close this for time being. We'll continue it tomorrow if it goes well, if everything goes well. Will continue, and it may become really extraordinary, we can say. I have seen that it may continue like this, and we read this. We'll discuss on these tables also, though these are in FPS. We'll see what to do with that. At least we can understand something out of this. That's a possible way. So thank you very much, gentlemen.